Example 3. Find the eighth term of the geometric sequence with a sub 3 equal to 36 and a sub 5 equal to 324. Now, when we did a problem similar to this in 9.3, you were able to use guess and check as an easier method, or maybe your knowledge of slope as an easier method to finding any missing terms or finding a specific term when you're only given two values to begin with. That does not work out quite as well with things that are geometric, so just keep that in mind that trial and error could potentially work here, just is going to be a little bit more challenging. Okay, so not that it can't be done, it just might be a little bit more challenging because we're multiplying by a factor of something to get from one number to the next versus like addition where we can use our knowledge of slope. Okay. Just like I did in the 9.3 lesson, I'm going to be using the general formula like we did in the last example to go through and solve this one as well, versus using guess and check. So to remind you, the general formula for something that's geometric looks like this. Now, just like when we used our general formula in 9.3 for things that are arithmetic, these subscripts and numbers within this formula are connected. So whatever I plug in for n for the subscript needs to be what I plug in for n in the actual formula itself. A sub 1 here has a subscript of 1. That is why I subtract 1 from n in the exponent. So if I don't have the first term like I do in this example, I can plug in any term number I want, and what that will do is it'll alter this formula to where I'll be subtracting whatever term number it is I plug in. And we're going to use that to find r in this problem. So I'm given the third and the fifth term. So I'm going to plug a sub 5 in for the a sub n piece on the left side. I don't have a sub 1, but I do have a sub 3, so I'm going to plug that in. Now n is 5 for where I have things plugged in so far. And instead of a sub 1, I have a sub 3. So instead of subtracting 1 in this exponent, I'm going to subtract 3. Because again, whatever this number is being subtracted, that's the term number I'm using here. Now I'm going to plug in the value. The value of the fifth term in this sequence is 324. The value of the third term is 36. Doing a little bit of simplifying, 5 minus 3 is 2. Solving for r, I'm going to divide by 36. That's going to give me 9 is equal to r squared. Then I'm going to square root both sides. Remember, I'm solving for a variable. So when you're solving for a variable and you square root it, that's going to leave me with a plus or minus 3. So what that means for us is we're actually going to have two potential answers because this is what's happening. We have the third term, which is 36. We don't know the fourth, but we know the fifth term is 324. We don't know. We know that we're multiplying by 3 every time, but what we don't know is are we multiplying by positive or negative 3? Because if we were multiplying by negative 3, we would still end up with a positive 324 for our fifth term. And if we were multiplying by positive 3, we would also still end up with a positive 324 for our fifth term. So what we don't know is we don't know if this middle term, if the even terms, a sub 4 or any of the even term numbers are positive or negative. We're not given that information. So we have two potential answers when we go through this process of now finding the eighth term, because we don't know if these even term locations are positive or negative numbers. So when we go through and find the eighth term, my final answer is going to be plus or minus because it could be positive or negative. We just weren't given enough information to make that sign determination right now. So to find the eighth term, this is what our math is going to look like. We're looking for a sub 8. I'm going to still stick with using a sub 3 and subtracting 3 here because that's the information I know. Now, r technically is a positive or a negative 3. All that's going to do is that in the end, my final answer is going to be positive and negative. So I'm just going to pick one version of 3 and stick with it for this math. If you would like to add in a plus or minus here just to remind yourself that at the end you're going to have a positive and a negative number, that's fine as well, but you don't have to. My exponent is going to be then 8 minus 3. A sub 8 again is what I'm looking for. The value of a sub 3 is 36. That's going to be times 3 to the power of 5. 3, whether positive or negative to the power of 5, would leave me with a positive or negative 243. Multiplying that by 36 will leave me with a positive or negative 8,748. So my eighth term is going to be either positive or negative 8,748. The last thing we're going to talk about is finding the sum of a geometric series. And that's, again, can be seen using summation notation. And finding the sum just means that you're going to be taking those term numbers from whatever beginning to whatever ending term it wants you to do and add them up, and that's it. There's a shortcut to do that, though, because just like with arithmetic, if you're adding together 50 term numbers, that can be pretty time-consuming. And so this is the shortcut to finding a sum when you're dealing with something that's geometric. So let's apply that to our last and final example of the school year, example 4. So the formula, just to remind you, is S sub n equals I flip pages. Here we are. A sub 1 times 1 minus r to the power of n over 1 minus r. So applying that, n is that term number that we're stopping on. So here it says find the sum from 1 to 4. So the term number we're stopping on is 4 because we're finding the sum of 4 terms total, 1 through 4. Then we need to find what the value of a sub 1 is. So I'm going to plug 1 into the rule that they give me, 3 to the power of k minus 1. That gives me 3 to the power of 0 because 1 minus 1 is 0. Anything to the power of 0 is always 1. So my value of the first term is 1. Now you could go through and find the value of the first, second, third, and fourth term and then add them up, and that would be fine as well. Or you can use this formula. Plugging all the numbers into the formula, we're doing S sub 4, finding the sum of the first 4 terms. A sub 1 is the value of 1. We're doing 1 minus, now r, we didn't actually go through and define yet, but it's given to us. R is the base of the exponent. It's 3. Our value of n is 4 because we're finding the sum of the first 4 terms. Doing a little bit of math. This times in by 1 on the outside really isn't affecting it because it's just 1. So I'm going to drop that off. So it's just 1 minus 3 to the 4th, which is 81. Divided by 1 minus 3, which is negative 2. So we get negative 80 over negative 2, giving us, a positive 40. So the sum of the first 4 terms in this series is 40. All right, and that is it. We are officially done with Algebra 2. After you complete the assignment, that is. So work on the 9.4 worksheet. If you have questions, please, please, please let me know. And it was so amazing being your teacher this year, and I'm so sad we don't get to say goodbye in person. But I hope you have had a great year, and if you need anything, let me know, and good luck.